Yes, AC through inductor we can study. Okay. So today we can discuss when AC is passed through an inductor. Last class we have discussed AC passed through a resistor, and what we have seen when AC is passed through a resistor, first we consider E equal to instantaneous value of EMF. E equal to E0 sin omega t is passed through the resistor. And that time current we found out current equal to E0 by R, that's equal to I0. So we got the expression I equal to I0 sin omega t. And phasor diagram also we have shown both on the same phase. So that is the relation between current and voltage when AC is passed through a resistor. What is the relation? Both current and resistance are, current and voltage are in same phase. What is the formula we got? We applied EMF E equal to E0 sin omega t, and the current when it is passed, when that EMF is applied across a resistor, the current passing through the resistor is found to be I equal to I0 sin omega t. Both voltage and current are in same phase. But when AC is passed through an inductor, they will not be in same phase. Let us see what is the phase difference between the current and voltage. There will be a phase difference between current and voltage. So here you can see the figure inductor. What is an inductor? Just a coil. For example, an insulated copper wire wounded in the form of a coil. Insulated copper wire wounded in the form of a helix or in the form of a coil. Coil is the wire. Insulated copper wire. And it is connected to AC source. What is an AC source? AC source means current at every instant is varying. Every instant current is varying, and the magnitude of current is varying every instant, and the direction versus
Teacher,
yes.
teacher Sneha admit you.
Yes. Two participants are with you. Who are they? Sneha, Adul Krishna, Pranavya. Okay. So when AC is passed through an inductor, we already know due to inductance, due to the property of a coil, it always opposes the change in flux. So when varying current is passed through the coil, AC is a varying current. Varying current is passed through a coil, flux linked with that will be changing because flux is directly proportional to I. Flux is directly proportional to I. So I is varying, so flux is varying. So as the current is AC, always at every instant current is varying. So the flux linked with the coil varies, and due to the property of the inductance of the coil, it opposes that change in flux. So an EMF will be induced, back EMF will be induced in the coil to oppose the applied EMF. Back EMF will be induced. Back EMF means opposing EMF. Will opposite to what? Opposite to the applied EMF. An EMF will be induced in the coil. Maya waiting. So when AC is sent through an inductor, what are things we can see? We can see many things. See, a back EMF will be induced. Why back EMF is induced? Flux linked with that coil is changing. How the flux linked with it changes? Because varying current is sent. Why varying current? Because it is AC. Every instant the magnitude is changing. After half rotation, the reverses the direction. First half cycle positive, next half cycle negative. So such a varying, this is a symbol of AC. So if a varying current is applied across an inductor, what happens? Flux linked with the coil changes, EMF will be induced, and that EMF will oppose the applied EMF. That's why it is called back EMF. So induced, we have studied that back EMF induced in the coil is equal to minus d phi by dt equal to minus of L into di by dt. Phi equal to Li, that is substituted here, and therefore we get induced EMF in the coil, back EMF in the coil equal to minus of L into di by dt. This EMF is opposing the applied EMF. So applied EMF should have a value at least equal to this. Then only we can maintain current in the circuit. So in order to maintain current in the circuit, the applied EMF should have a value at least equal to the back EMF. So here, to maintain the flow of current in the circuit, applied voltage must be equal and opposite to the induced voltage. So applied EMF capital E is equal to minus of this induced EMF. So minus of minus L into di by dt. That should be, at least that should be there. Then only we can maintain current in the circuit. So E equal to applied EMF, we got negative of the back EMF. That is equal to plus L into di by dt. And we know the equation for applied EMF is equal to E0 sin omega t. From that, we have to find out di. Take di from that, then integrating that we get the total current. Then we can find out the phase difference between voltage and current. So we start with the equation E equal to E0 sin omega t. And we know when that EMF is applied across an inductor, EMF will be, back EMF will be induced in it, which will oppose the applied EMF, and therefore the applied EMF value, negative of the induced EMF, that should be applied to maintain current flow in the circuit. So applied EMF must be equal to minus of minus L into di by dt. That's equal to plus L into di by dt. So that is the applied EMF. Now, from this equation, what you have to take? Di. For what? You have to find out the phase relationship between EMF and current. So from this equation, you take di and then integrate that to get total current I. Then we can find out the phase difference. Okay, next step we can see. Yes.
ഇത് ഞാൻ എൻ ടാബ് വഴിയല്ലേ കേറിയത്.
Okay. Name?
Sneha.
Sneha. Why you didn't join? That's a problem. You have to, sometimes your attendance may not mark. That is a problem.
ടീച്ചർ അതില് ജോയിൻ ചെയ്യേണ്ട ഇത് വന്നിട്ടില്ല, ലിങ്ക് പോലെ വന്നിട്ടില്ല, ജോയിൻ ഓപ്ഷൻ വന്നില്ല അവിടെ.
ആണോ? I don't know why. Others got no. Okay. Okay. I will mark it.
ടീച്ചർക്ക് സ്ക്രീൻഷോട്ട്
I will mark attendance. You send the screenshot. Okay. Then, now we got the expression for di. di we got. Di equal to 0 by L into sin omega t dt. Then integrating both sides, we get total current. I, integral di is I, equal to E0 by L is constant into integral sin omega t dt. E0 by L into integral sin omega t is minus cos omega t. Again, you have to differentiate this part. And d by dt of omega t. What is it? You are all knowing differentiation now. Because you have studied differentiation. What is d by dt of omega t? Omega into dt by dt. Omega into dt by dt is omega. So, with that factor, you have to divide. In differentiation, we are multiplying with that factor, but integration, we are dividing with that factor. When you study integration, you will learn more about that. So, integral sin omega t is minus cos omega t. And again, you have to differentiate this expression, d by dt of omega t, and with that factor, you have to divide this. So, minus cos omega t by omega, you are getting. Now after integration, integral sign is not there, dt is not there. Only that formula is applied here. Okay. Then next, I equal to minus sign is taken outside. Minus E0 by L omega cos omega t. Then you have to remove this negative sign. See, cos omega, next step minus E0 by L omega sin cos omega t is written in terms of sign. Why? Because we are going to find the phase relationship between voltage and current. A voltage formula is E equal to E0 sin omega t. So in terms of sin, first we write, and omega t also should be there. With the omega t, what you are adding, what you are subtracting, that is the phase difference. So in order to find the phase relationship, we have to express current also in sin form. So that's why cos formula is changed. Actually, this is the formula for current, but we are expressing that in terms of sine. So minus E0 by L omega sine minus equation. See, actually omega t plus 90 and omega t minus 90 both will give cos omega t. Sine of 90 plus theta or sine 90 minus theta both gives the same value. So here actually 90 minus omega t will give cos omega t. Similarly 90 plus omega t also will give cos omega t. But we are taking minus term sin 90 minus omega t because this negative sign we want to remove and we have to express omega t first. Because in the equation for voltage E equal to 0 sin omega t. So with that omega t you have to write plus or minus. Then it will be easy for us to find the phase difference. With omega t what you are subtracting. With omega t what you are adding, whether it is pi, whether it is pi by 2, whether it is 2 pi by 2, like that. We have to find out the phase difference. For that we are expressing in this form. So first we wrote in the form cos, after integration we got the equation, cos equation we got. Next we are expressing that with sine equation, but we selected this one 90 minus omega t because when you multiply that minus with this minus, this omega t becomes positive. We need positive value of omega t. So sin omega, that's why we selected this equation. So we need plus omega t. So minus into minus becomes plus. So plus omega t we got. So when you multiply this minus with these two terms, omega t becomes plus, but pi by 2 becomes minus. So we get omega t minus pi by 2. Now you see, now you can compare both the equation. E equal to E0 sin omega t. I equal to I0 sin omega t minus pi by 2. Why this becomes I0? You know how this becomes I0? Because we voltage L omega, you can see the current will be maximum, that is I, peak value of current is represented by I0. Current, when is this current equation? That means according to this equation, when we get maximum current? When omega t minus pi by 2 takes its maximum value. That means 90. So for example, when this takes its maximum value, we get the current maximum. So we can, when sin omega t minus pi by 2 is maximum value of sin is 1. When this is maximum, we get peak value of current. So peak value of current is represented as I0. I0. So I0 becomes what? E0 by L omega. Because this factor, when current takes its maximum value, this factor becomes 1. So I0 equal to L0 by omega. So this according to Ohm's law, I equal to E by R. I equal to E by R. So this factor is actually the resistance, or we cannot use the word resistance because resistance is only for resistor. So this factor is known as reactance, inductive reactance. Actually, it is the opposition offered by inductor to AC current. So E0 by R is the current. So here there is no resistor, we used only inductor. So what is this? This is the inductance. It is known as reactance, not inductance. L is the inductance. L omega is the reactance, not resistance. Resistance is the opposition offered by the resistor to AC current. But what is reactance? Reactance is the opposition offered by inductor to AC current. Inductor also offers some opposition to AC. But it will not oppose DC because flux is not changing. Now back EMF is produced. So it will not offer any resistance to DC, any opposition to DC. But inductor offer an opposition to AC current. And that opposition offered by inductor to AC, that is known as reactance. Reactance. Then it is XL, it is denoted with XL, X suffix L, that is written. That's written in the next page. So I'll explain that time. So this is the reactance offered by inductor to AC current. It is taken as X suffix L, reactance, inductive reactance. It is the opposition offered by inductor to AC. And now we are going to find the phase difference between current and voltage. Voltage equation E equal to 0 sin omega t. And we got the expression for current I equal to E0 by L omega, that we have taken as I0. So I0 sin omega t minus pi by 2. So I equal to I0 sin omega t minus pi by 2. And we can see with omega t we minus 90 or pi by 2. So this is the phase difference between EMF E and the current I, instantaneous value of current I. E equal to 0 sin omega t, that is the instantaneous value of EMF applied. And instantaneous value of current obtained is I equal to I0 sin omega t minus pi by 2. That means they are not in phase. Here there is a phase difference between the EMF and current. What is the phase difference? Here see, this current is lagging. We say it is lagging. Minus pi by 2. Current lag. Voltage is leading. So with this, if you add pi by 2, we get omega t. So current is lagging. When AC is passed through an inductor, current lag, but voltage leads. Understood. So this is the phase difference between current and voltage in inductive circuit. That means when current is passed through an inductor only is there. So comparing equation 1 and 4, what is 1? E equal to 0 sin omega t. What is 4? I equal to 0 sin omega t minus pi by 2. So what is the phase relationship we got? The current lags the voltage by a phase angle of pi by 2. Current lags behind the alternating voltage E by a phase angle of 90 degree. That is by 1/4 of the period. 1/4 of 90 means 1/4 of the time period. 0. First see 90 degree means rotating means 90 degree means it is 1/4. Then 180 degree means half rotation, and 270 degree means 3/4 of the rotation, and 360 degree means full rotation. AC, when we discussed AC, I explained the rotation of the coil by 1/4 of the time period. What is its position? It will be, coil will take 90 degree like that. So here, in the case of AC, one cycle of AC, time period when we discuss 0, t by 4, t by 2, 3t by 4 and t. Like that we have to consider time period. So what is the phase difference? Question will come. When AC is passed through an inductor, show that current lags the voltage by a phase angle 90 degree. Or question will be like that. What is the phase relationship between current and voltage when AC is passed through an inductor? Show that. Explain like that. So you have to study the derivation. We know this exam, it is short answer questions also will be there. Portions are already given in your group. L omega is the opposition offered by inductor to AC and is known as inductive reactance. I told you now it is represented by XL, suffix L. XL equal to L omega. XL equal to L omega. L into 2 pi into nu. For doing problems, you should know the formulas, different formula. XL. What is XL? Inductive reactance. What is the equation? L omega. What is omega? 2 pi into nu. Okay. Nu is the frequency of AC. 50 cycles per second. Next, graphical representation of this when AC passes through an inductor, the relationship we can express in a graph, expressing the relation between voltage and current in a graph. You know the formula for AC alternating EMF E equal to E means instantaneous value of EMF. I means instantaneous value of current. E0 peak value of EMF. I0 peak value of current. How you get peak value of current? Peak value of EMF by inductive reactance XL. What is XL? L omega. What is omega? 2 pi into nu. Just Sulaja teacher is waiting. Welcome, Sulaja teacher. Okay. So here you can see the equations for alternating EMF E equal to E0 sin omega t, and the relation for current I equal to I0 sin omega t minus pi by 2. So when we plot the graph, first we can plot the graph for the voltage. Here along the x-axis we take omega t, and along the y-axis we take EMF or current. Both we can take. So first we take, when we take current, first we take voltage E equal to 0 sin omega t. That graph is plotted. So at 0 time, when we apply this in this equation, omega t 0. Omega t 0. What is sin 0? Sin 0, 0. Then pi by 2 give. Pi by 2. Sin pi by 2, 90. So it takes the maximum value. So we get E equal to E0. Then next we take pi. Sin pi. What is sin pi? Sin pi is? What is sin pi? Sin pi is 0. So we get again 0 itself. E equal to EMF becomes 0. Then 3 pi by 2, that we get my negative value. So minus is 0. Again 2 pi. So that becomes 0. Similarly, current equation also you have to substitute all the values. I equal to I0 sin omega t minus pi by 2. So first give omega t 0, that means initial position. What is the current? We can find out at initial point, 0 origin. What is the current? So put omega t 0. So what we get? Sin minus pi by 2. Sin pi by 2, that is 90. Minus, this is minus pi by 2. So answer becomes minus. Minus I0. So here minus I0 is marked here. Negative peak, negative maximum, negative maximum. And all values first you find. So first you give the value omega t 0. Next case omega t is pi by 2. So pi by 2 when you give it here, pi by 2 minus pi by 2. What is it? 0. Sin 0. Sin 0 is 0. Then next pi value you have to give. Pi minus pi by 2, that is again pi by 2. So it takes the maximum value, positive maximum, I0. So giving the value of this omega t, first you write the instantaneous EMF all values, you write instantaneous current all values you write, and then you plot the graph. So let us plot the graph for E equal to 0 sin, first value 0. Then peak value is 0. Again 0. Pi. See, this is 0, pi by 2, pi. And this is 3 pi by 2. And this is again 2 pi. Okay. So next value is 3 pi by 2 minus E0. See, this is minus E0 peak value in negative direction. And then 2 pi, when it reaches 2 pi, then what happens? The value of E becomes 0. So that green pen, I have drawn the graph for this EMF and omega t. That graph is plotted. Okay. So we get the curve like this. And then for current, when you plot the graph, you see current, see when EMF is 0, current is having the negative maximum value. That is why it's they are not in same phase. They are having a phase difference of pi by 2. Okay. And here got I, current is lagging. Current is here. EMF already is here, but it is coming only. See, lagging. So current takes its peak value, negative peak value minus I0 when EMF takes the 0 value. And then you see when EMF is the peak value, current is having the 0 value. Like that. It is coming behind. Current is coming behind the voltage. Lags behind. Current lags the EMF by a phase angle of 90 degree. That is the curve is drawn. We can see they are not in same phase. There is a phase difference and current is lagging the voltage by a phase angle of 90 degree. Usually phasor diagram asks. Phasor diagram is important. Phasor diagram, it is now drawn. This is the phasor diagram. See, phasor, this is the phasor diagram. This x-axis and y-axis, we always represent E0. E equal to E0 sin omega t. That is the equation. So omega t phase angle is shown and E0 vector. E0 vector is shown and it is rotated. That vector is rotated in anti-clockwise direction. So vector E0 is marked here. And next we have to show the phase relationship for current. And we know current, we have already proved current is lagging the voltage. So so you have to rotate in the anti-clockwise. If the current is leading through 90 degree, we have to mark 90 from here. You have to take 90 degree from here E0 position. 90 degree you have to mark and then draw that graph here. If it is leading by 90 degree, if the current leads by 90 degree from E0 vector, we have to rotate through 90 degree and we have to plot that current graph. But here in an inductor, that happens in a capacitor. But you know, in the case of an inductor, the current is lagging. So we have to rotate it through 90 degree. That means not anti-clockwise, clockwise direction. Anti-clockwise direction is considered as positive and clockwise direction is taken as negative. So we have to rotate the vector, current vector through 90 degree from this vector, E0 vector. Rotate through in clockwise direction through 90 degree and draw that vector I0. And we know I0 magnitude is less than E0. What is the equation for I0? E0 by XL. What is XL? What is XL? I'll ask to Nandana, what is XL? I told I0 equal to E0 by XL. What is XL, Nandana? Nandana. Sneha, what is XL?
Yes, teacher.
Nandana, tell what is XL? I told you, no. XL suffix.
ടീച്ചർ എന്റെ നെറ്റ് പോയിട്ട് എനിക്കൊന്നും കേൾക്കാൻ പറ്റിയില്ല. ഞാൻ കുറച്ച് മുമ്പ് വന്നുള്ളൂ.
Okay. No problem. I'll ask you another one. Then Steffi, what is XL? Steffi.
ടീച്ചർ
What is X suffix L? What is it?
എക്സ് സഫിക്സ് എൽ.
What is it? E0 by XL. I told I0 equal to E0 by X. EMF by its, what is it? Not heard?
L omega.
L omega, correct. L omega. It is known as inductive. Inductive. Do you remember that
Inductive.
reactance? Inductive reactance. XL is inductive reactance. So always it will be less. I0 is E0 by XL. XL is the reactance. Reactance, inductive reactance means what? It is the opposition offered by the inductor to AC, just like a resistor offer resistance to the current, just like that. Resistor offer resistance to current, just like that. Inductor offer some resistance to AC. That is known as inductive reactance. But you know, it will not offer any resistance to DC current. The inductor offer resistance to AC only. That opposition offered by inductor to AC, it is known as inductive reactance. Amaldeep, what is inductive reactance? Amaldeep. Amaldeep. Amaldeep is not answering. Others. 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 Answering. Vishag. 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 Where is Vishag? Vishag is there. Vishag also not answering. Namrata is there? Namrata?
Yes, teacher.
What is inductive reactance?
The opposition offered to current by coil.
Which current? Which current? AC or DC?
AC.
Will it offer any resistance to DC? Inductor?
No.
No. Why?
അതറിയില്ല ടീച്ചർ.
Because flux is not changing in DC. Steady current. AC current is changing. So flux is changing. Pi equal to Li. Okay. Then EMF induced is L di by dt. Okay. So EMF will be induced, opposing EMF will be induced when the flux linked with that changes. When flux changes, current in the circuit changes. Okay. So in AC only inductor offer resistance, or that resistance offered by the inductor, that is known as reactance. Don't tell resistance of inductor. It is reactance. Okay. Resistance is only for resistor. Correct.
ടീച്ചർ റെസിസ്റ്റർ അപ്പൊ ഏത് കറണ്ടിനെ റെസിസ്റ്റ്
Both current. Resistor will decrease both the current. Okay. Malaysia is waiting. 34. In the beginning, 37 were there, but now only 35. To the next problem. So, what all things we have seen here? The phasor diagram. Phasor diagram is important. The current is lagging. Yes, current is lagging the voltage by a phase angle 90 degrees. So from this graph you should be able to explain all. What is E0? E0 is the peak EMF. What is I0? I0 is the peak value of current. What is the phase angle, phase difference between them? 90 degree. And which one is lagging? Current is lagging by 90 degree. So what is the equation for the instantaneous value of EMF? E equal to 0 sin omega t. What is the induced EMF? Minus of L into di by dt. So applied EMF should have a value E equal to L di by dt, which is equal to E0 sin omega t. And we obtain the expression for current I equal to T0 by L into integral sin omega t dt. When we have integrated sin omega t, integrating what we got? Minus cos omega t by omega. All this I explained. If you have doubt in this step, you can ask. Anyone? Any doubt in these steps? You can tell me. See this, we got this expression and we cos omega t is changed into sine function, and we selected pi by 2 minus omega t because we have to get an expression with the positive omega t. So negative sign is already present here. So when we multiply the negative sign with the minus omega t, that becomes positive. So omega t minus pi by 2 we get, and we showed this factor is the peak value of current, that is I0, E0 by XL, E0 by XL. That's why we took XL equal to L omega or this one. So we got the expression for current, I equal to I0 sin omega t minus pi by 2. And comparing what we get, current is lagging the EMF by a phase angle of pi by 2. So always remember this formula, I equal to I0 sin omega t minus pi by 2. Lagging. Inductor, current lags by a phase angle of 90. And then phasor diagram, important, very important question. And this phasor diagram is more important than this graphical representation. This is just for knowing. Then next, when AC is passed through a capacitor, what happens? Let us see. Let us begin that. So you can see a capacitor here. Capacitor we have studied in second chapter. All factors about it we have learned. So here when AC is connected, the alternating EMF we represent instantaneous value of EMF equal to E0 sin omega t. That is applied to the capacitor. Then we have to obtain the equation for current. What is the phase relationship between the voltage and current? So we should get an expression for current. We know I equal to dq by dt. So we have to start with that equation. See, voltage, we have studied this formula, V equal to Q by C. V equal to Q by C. At every instant, potential difference V must be equal to the EMF applied. V equal to Q by C equal to E. EMF applied must be equal to Q by C. So that's equal to E0 sin omega t. This equation we have studied in the second chapter. V equal to Q by C. And that should be the applied EMF. Applied EMF value, instantaneous value of EMF equal to E0 sin omega t. So when we get Q, we can easily find out current. How? Q equal to C E0 sin omega t. When you get Q, differentiating that with respect to time, we know rate of flow of charge is current. So when you get the expression for Q, we can find out the equation for current, I equal to dq by dt. I equal to dq by dt. So d by dt of what is Q? Q equal to C E0 sin omega t. So differentiating that, we get the expression. Differentiation you already studied in maths. So it's very easy now. C is constant, C is 0. E0 peak value, that's why it is taken constant. E0 is taken outside. Peak value means maximum value, that will not vary, that is constant. So C is 0 in the differential d by dt of sin omega t. You already know that is cos omega t into omega. So next. So we are expressing that in the form of E0 by 1 by C omega. E0 by 1 by C omega. See? C omega, we are writing, in the next step, we are writing E0 by 1 by C omega, like that. Same meaning. E0 by 1 by C omega, because we have to find the equation for current. E0 by 1 by C omega we are writing. And what by 1 by C omega, it is taken as the position of it by capacitor to AC, capacitive reactance. It is denoted by the letter XC. You can see. XC equal to 1 by C omega. Omega equal to 2 pi into nu. Nu is the frequency of AC. Do you know what is the frequency of AC we are getting in our home? Frequency of AC?